Are you going to turn there?
Great. So welcome to another exciting monthly edition of the Focus Follow-up workshops. Today we are joined by Jack or Jacqueline or Joaquin, coming to us from Colorado. It's wonderful to have you with us. Longtime e-NABLE volunteer. Jack's been involved with e-NABLE since 2016, 2017. By day, he's a software engineer, but at college, came to the fork in the road between computer science and sculpting, and made his way back towards hands-on design work with his participation within e-NABLE. Has been involved with several different devices like the Lionel hand with prosthetist Jeff Aaron Stone. Today, he's going to give an orientation and deep dive into the Kwawu 3, the latest design and an e-NABLE open source project, transhumeral arm. There's several different styles and some new explorations into materials. So with that, thanks so much, and take it away.
Hey, thanks for that great introduction.
If you don't mind, I'll just jump in real quick to say everyone should feel free to use the chat to post any questions or comments as we go here, and I'll try to keep an eye on those, and time permitting, we'll get to them at the end. Otherwise, we can always follow up on things after the fact. Thanks, Jack.
Yeah, anything that I miss or whatever, email. Better yet, just go ahead and ask on the e-NABLE hub, right? So everybody can get the answer. I love doing that. I get multiple emails a day on this topic, so I don't mind answering them. So I'm just going to go through the questions that Ben emailed, and it looks like Jeremy got all the good questions in. So hey, Jeremy gets his questions answered, but feel free to sort of again ask more as we go on. So I'm just going to kind of roll through that email and do those questions, kind of deep dive on each one of them. And so I'm going to do a lot of screen sharing because it seemed like the right way to do a deep dive, and I'll try and do that as long as that works. So I'll start with Jeremy's first question, more about the flexible plastic being used. I assume you meant, and I'm holding up my camera as well, this plastic here, right, that is in the wrap design. You can either do plastic or you can do leather. And I'll say it again, the leather is more comfortable and I generally prefer it. Whenever I go on these calls, I start to lose names, but the leather, of course, comes from.
Jack, we should point out, sorry to jump in, we should point out if any of these questions seem kind of out of context or you're not clear, we'll share the link to the last session where Jack gave us an overview of the design, and you can better understand kind of where some of this came from. So I just wanted to point that out, that this is a follow-up to an overview that was provided for anyone that hasn't seen that. It's worth watching.
Fair enough. Fair enough. So yeah, the leather clearly comes from the other designs leather in e-NABLE, and him sort of cornering me at one of the first e-NABLE meetings and saying, you really should be using leather. And he's right. But the question was about the flexible plastic. It's not, it is still PETG. There's nothing special about the plastic. It is the print pattern. And I shared here sort of my inspiration, which are these, this is wood, and laser cutting wood is kind of a common thing, laser cutting 1/4-inch wood. And somebody at our makerspace had these things lying around, and I was playing with them and took a quick photo of them and was like, this is really cool. I bet that would work in plastic. And so I just started toying with all those different designs and sort of ended up with what they call the straight design. And it really is in the, so if I share, I'm not sure, it won't just let me bump from one to the other, right? So when you do it in OpenSCAD, right, it really does output the STL with these little slots in it. And so then when you print it, it prints it with the little slots. I was looking, I know I took a bunch of video where we printed these out, and I mean, all through 2021, we printed a bunch of these, and we would then stretch them and fold them and see how they did, right? So this is a photo I had where we had printed this out, and we would adjust the sort of length and width and size of those slots
I think we lost your screen share. We're not seeing anything but you now.
Oh, sorry. There it is.
There you go.
And so we just printed, all I was just getting at is we printed a lot of these out, and then we would hook them up to a force meter and sort of pull on them and see when they broke with a force meter. And so that's a break that broke in a different spot. This particular photo is the inspiration for why there's 2mm rods, because I couldn't get away from that spot breaking any other way, which was not a question answered. But when you go to make this version, you'll see there are actual 2mm steel rods that I just couldn't get away from that are in that connection, because no matter what I did, it broke there. But that's sort of the flexible, it's a design in the plastic. It's not a special plastic.
Okay.
In the code, if you look at the OpenSCAD code, all those parameters we mucked with are still variables. Let me see if I can find it really quick, since we're on a deep dive. If I can, I'll share back to that. Yeah, it's right here. Okay, so let me, won't let me just jump directly from one share to another. So there's the OpenSCAD, right, that I had a second ago. I opened the code up, and you can just change the slot spacing width right there. They're sort of hard coded in there. I didn't make these parameters because we spend a long time getting to those numbers. And, yes, can you get slightly better behavior on your printer? Perhaps, which is kind of why I left it in there, but unlikely that you'll get much different behavior. So that's that question. Anything else, Jeremy? Was that the right question you were asking?
It was. And just to provide a little context, the reason I was asking is we've got a group, we've been working on a new design, and we're exploring the use of chainmail, incorporating this to achieve some of that same sort of flexibility. But I was wondering kind of how your approach would compare, because it seems like yours gives more flexibility in the sense that you can form it the way you need, but then it's got a little bit more rigidity, whereas this, has a lot more kind of give to it. So I think we're looking at using it in different ways. I was just kind of curious.
Yeah.
How that compares.
Yeah. So I looked at a pattern. A couple of the patterns are like that. And this sort of shows, I wanted it to hold some shape on its own.
Yeah. Okay.
Right? Because for somebody with two residual arms, they need that to have a little bit of shape so they can get it in there.
Absolutely.
They need it to hold it open. In all cases, the thickness of the leather, the same thing. I want it to hold a little bit of shape so they can sort of start getting their hand in there on their own, because often they're kind of going this and then shoving the other hand in there, and they don't have, the ability to sort of open something up that's totally free form.
Yep. Good point.
So I kind of went away from that idea to something that had a little bit of stiffness. I wanted maximum sort of wrap in that direction, and nice and tight and strong. I think when I pulled on the chainmail pattern and I printed that, I didn't have as much sort of pull as I wanted either, right? So, and it didn't pass I have I forget, I attribute it to Jeff, but there's the sort of strength pattern is I have to put it on the floor and stomp on it. And, that's the strength test, right? So that goes back to the strength test method for grip, and Eric's online. This is totally Eric's method. He came up with it. He showed it to me in one of my visits to his lab. You get a pressure cuff, you wrap it up, you give it a little bit of pressure, right? And then you put it in the hand and squeeze, right? And then you look at how much pressure you can get when you squeeze the hand. Generally, I can get up to about 30 pounds, 30 PSI roughly is what it achieves. And I just haven't been able to get much better than that. I think I'd have to go to a very different design to get much more than that. By comparison, if I just squeeze it myself, I can peg it at 300. So at most,
I gotta say, kudos to Eric on that. That's a brilliant.
Yeah, it's really straightforward. I use it a lot, right? It drives these types. I like to be data driven, right? I'm an engineer. I want to be data driven on design. So this type of thing where I can make an adjustment, make a hand, do this, and see if there's an improvement. And I've done a lot of different adjustments, and none of them really make any grip strength difference. I mean, some are terrible, right? Have no grip strength on, because this only goes down to 20. And but anything that I like doesn't really get much better than 30.
Yeah.
And
Eric
kind of
points
in that
out that
range, high 20s. 30.
Eric points out that they use that to assess grip strength in stroke patients.
Yeah. Okay.
So,
Yeah. So maybe that's where he got it. I got it from him.
Yeah.
Along those lines, I'm going to share another thing with you. This doesn't answer your question, but it kind of is a lead in. This is a little video of the box and block test that we do pretty often as well, right? I couldn't find a video of the Kwawu. This is actually the two-tree hand on a Kwawu arm. And we just try this a lot. This is another sort of data-driven thing that we do a lot to see, hey, how is, have we made any improvements? Have we made anything better, right? And the box and block test is another sort of standard test in physical therapy. And it's generally used like in stroke patients or other patients, see how well the physical therapy is doing. You have a certain number of blocks on one side. You have exactly 1 minute to move blocks from one side to the other side, and you just count how many you moved over. An able-bodied person can do quite a few, 40, 50 in that range. And with these hands, with the Kwawu hand, you're up in the 20s again, so pretty good. Quite frankly, I have some videos with the other arm, with the arm that has the Phoenix hand on it. We could move like 3. It's just, you just can't grip the block at all.
That's
right.
terrific. Hey, if a quick question here, if you don't mind, because we've been talking about how this is an area where like some of the school groups and educational groups could definitely help out, as opposed to just trying to make hands for people, helping us to gather these data points and do this kind of testing. I'm looking at your setup there, and it looks to me like there's kind of a standardized approach in terms of the maybe the dimensions of that box, the height of that wall, et cetera. Has anyone shared those designs? It looks like we're using laser cutting plus some 3D printed corner widgets there.
Yeah.
Has anyone shared that with the how-to?
Yeah, don't mind at all. I mean, the design, it is a standard, the box and block test is a standardized test. So you can just Google it and it will tell you sort of those heights, and block sizes are the most important, and heights of the walls. And that's a standard physical therapy test that you could look up. Excellent. And then we just made our own.
Eric just shared a link to that, so we'll make sure to share this when we share the recording. Yeah. Thank you, Eric.
And since Eric's online, I'll give him credit for that contraption too, right? I'm free scream. No, that's the wrong, right? Oh yeah, you can see the contraption where we're holding the arm in there. Yeah. Again, totally inspired by Eric. Did the same thing for the Phoenix hands. And so we came back and said, hey, we should do this for the arm too. And so the contraption that we're using to hold the arm onto our able-bodied arm, I'd like to redo that, right? That could use some work, right? We sort of bubble gum and scotch tape that together, but we were just trying to get to a test, right? And this is an early video, probably taken 2 years ago, and but it's one I had on hand. But again, it's sort of, I want to drive home the idea that, yeah, data-driven. And yeah, I totally agree. This is the type of thing that classrooms can do more of. I ran this with like a dozen people, I would corner friends and family and go, hey, come here. and that's not a huge number, right? It would be good to do with more numbers. Totally agree with that. The hand. So you asked about the hand itself. Yeah, and we will jump into sharing that. Let me stop this share, and I'm going to share Fusion 360. Actually, that will answer the next question. The original hand I sculpted in Blender and just hand sculpted by hand. And sculpted it based on my own hand, right? It's kind of went like that and was like, you know, and did it in Blender.
Okay, that's
I couldn't find the Blender file, right? So I then imported it in Fusion 360, and this is the import into Fusion 360, right? And so it came in. I just and their techniques in Fusion, right? I basically brought it into Fusion and then do what they call a shell wrap around it, and so it came in as a static model. And then once I got into Fusion as a static model, started carving it up. So I sculpted it specifically in this hand position because that's what I wanted this sort of natural hand position to be, for various reasons. That's a sort of relaxed hand. I chose my own hand because it was convenient. It's my own hand. And I happen to not have a particularly masculine hand, right? My hand is kind of, you know, it's bigger than most, but that wasn't a problem. But its proportions are sort of not specifically male or female. So I figured, good enough. When I was doing that in Blender, I actually, when I sculpted it, I used the NURBS and all of those things. So even after I had sculpted it in Blender, I had it parameterized so you could enter finger length and palm width, and it would adjust the hand using the built-in Blender's NURBS thing to make different hands. And I really thought, oh, that's what I want to do. I want to be able to let somebody sort of enter each finger length and get a hand that looks like their hand with a few different parameters. Never went anywhere with that because I couldn't make the connection from NURBS in Blender over to parametric in Fusion 360 to OpenSCAD, right? There was just a bridge too far. But it is something that I would like to go back to someday, right? If I could ever get one thing where I could do NURBS and OpenSCAD and bolts all, you know, in one thing. And that's possible.
We haven't done it using that exact approach, but we have a team that has struggled with some of these issues and has made some pretty cool progress. Alexander is on this call. Might want to connect with him in the future if you decide to take another stab at that, because he's done a lot of great work for us in terms of how to create a fully parametric design like this. And I see that you have kind of a solid hand here. Are you then kind of taking for the joints, are you kind of cutting out negatives to?
Right.
See, that's what we
cut out
too,
negatives.
yeah.
So if
we're working on a lot of the same challenges here. Definitely should compare notes at some point.
Yeah. So I go here and then I cut out, right? So you can see this is the same sculpture and then cut out the different pieces.
Yep.
And that's basically how it's designed. So when in the relaxed position, it forms a nice sculpted hand.
Yep. Very nice.
Yeah. And it just moving from that again, from something like NURBS over to something like this, over to something like bolts. It's possible to do, but I don't think I can do it with these tools.
And how about on the assembly side for your hand? Are you using 3D printed pins? Are you using hardware? How are you actually assembling the components?
Now that's a whole long question. I have 6 videos on assembly that 8 videos on assembly that I keep trying to get finished. But can you be more specific? I mean,
well, I'm just wondering, so it's not a print in place design, so you have to use something to kind of connect the components together. Are those 3D printed pins like in the Phoenix hand, or are you using like metal hardware like screws, like to go through the finger joints and that kind of thing?
Oh, so the finger joints are classically TPU.
Okay.
That is the part that's printed in, and answer your next question, the difference between 95A or 82A TPU. That rectangle, right, is where the TPU goes.
I see.
Right?
Okay.
Right. So that rectangle is filled with TPU, and the rectangle is extended from the inner finger through the outer finger. And then when you rotate the hinge, right? So there we go. Right. There we go. So there you can see the TPU in there, so that when you bend it, the TPU bends.
Got it.
And then or twists and then untwists.
And that's creating your resistance then.
And that's creating the resistance and the form back.
That
has been the part of the Kwawu sort of since the beginning, right? Is the TPU hinges. I like TPU hinges a lot. They never wear out. TPU is virtually indestructible.
And have you found that the 95A can be used, or is that too rigid for this?
No, so this hand is a 95A. So that was sort of your next question, is I tried to make modifications from the 95A. Originally, I said, look, only 82, 85, low 80s would work, and 95 just wouldn't work. So I tried to make modifications, and I'm pretty happy. That hand I just showed you is 95. Most of the hands in my demo video are all 95. Only if you have a super sort of small kid's arm, might you sort of notice that, hey, I'd really rather have the 82. The 82 is always sort of a little more bouncy, and so I think has a better return. But the 95, right, is still pretty bouncy and still has a pretty good behavior to it. Right? Okay. And what I did, it turned out to not be magic. This is the version 2 hand, and you can sort of see this distance here, the depth. There's a carve out in that finger, in the inner finger. And then all I did when I went to the version 3, and maybe I thought this was obvious to see, but now that I'm looking at it, maybe it isn't, right? This depth here is a lot deeper. And this hinge, you can't really see that, is slightly thinner. Okay. And by making the hinge slightly thinner and the depth gives more space for the twist to happen. All right, by carving out more, so there's more hollow space inside that finger for the twist of the 95. The 82 can sort of twist in a really tight space, whereas the 95 just needs more space for twisting. And it can't twist as tightly. And so that's all I kind of really needed to do. There are a couple other tweaks and whatnot that I did, but that was in the end the one that really was the magic that made the difference. So it's just sort of after a while thinking about it, being, oh, okay, I guess that's all it needs.
Yeah, really smart design.
So that sort of answers your next question about TPU 95A versus 85. TPU comes in a lot of hardnesses. There's a short A hardness scale, which goes much broader, goes up to 100 and some and down to 20 some. We need to stay in between 80 something to mid 90s. You can buy TPU up in the hundreds. That won't work, right?
I just want to share. I want to share the latest post from Eric here in the chat that he finds it easier to assemble the kinetic. He finds this easier to assemble than the kinetic, which has those split hinges. He says he hasn't had any problems with lateral slipping of the hinges in the Quau, so he's not convinced the split hinge of the kinetic is necessary. I was curious about that myself because I have made a kinetic. I haven't made one of these yet. So
yeah, I haven't made a. Yeah, good observation, Eric. I haven't made a kinetic, and I want to.
I heard that from somebody else. Bob Rieger was one who has kind of taken it upon himself to make all these different designs. And I remember his feedback on the kinetic was he always had a very hard time getting those TPU hinges into the fingers, getting them installed into the slots was always very challenging. So
yeah, it looks like, and I haven't made a kinetic yet. There's sort of a bone hinge design, and I had a bone hinge thing before, and I found that hard to. I liked this twist better than the bend. Though I like the behavior of the bend, so I wanted to make it. And there's some other things. Well, in between last week and this week, and I'm gonna completely mess up his name. Christoph. I'm just gonna say Christoph. Christoph Grandy. Maybe that's how it's pronounced. Send over some ideas for how to form. He made a post on doing silicone in the fingertips and silicone inserts, and I want to follow up with that. I think it's a great idea, and I'm going to follow up with him on that. But as an aside, other people in the past have used silicone. They've silicone molded the hinges, and these are fairly easy. It's a rectangular or simple rectangle, so it's pretty easy to do a silicone mold. And I just want to follow up with that because the problem is always getting the right silicone. You can't just get silicone mixes. They're hard. There's a million of them out there is the problem. And you need to get exactly the right mix. And that can be very hard to sort of explain to people out there. They just go and buy silicone and use it, and it doesn't work, and they get confused. And I'm like, there's hundreds of silicone mixes out there.
Yep.
You got to get the right one.
We actually had a presentation earlier today from Nate Monroe, who's another designer in the community, and he did some work with silicone molding and mentioned a tip that he finds that by coating the mold with a diluted dish soap, he finds that to be a very effective way of preventing it from sticking in the molds and getting an easy release.
Yeah. There's lots of good release. I love Nick's work, right? Nick at least here is in Denver, so I can see him more often.
One other comment from Eric here. He says his problem with the Kwawu has been the side of the palm near the pinky can crack, and he's wondering if that's something that you fixed in the current version of the design.
Yes, that is fixed in the current version of the design, and let's see if I can update it. So the big change in version 3 here, and I'm just going to show it because I have Fusion open, right, is if you remember, Eric, there were 2 slots here before. Now there's only 1 slot, and you tie the string off at the end of the finger, similar to a phoenix hand. And so now, since I only have to run 1 string up instead of up and back, I can make I went ahead and made all of these parts thicker. So the part he's talking about is the part he's talking about is this part right here, right? And that has been made thicker because I only needed 1 slot here, so I could thicken this up. And you can kind of see, if I were to open up the version 2, the difference. This center part here of the flange is thinner, making this part thicker. So yeah, definitely done. Also, since there's only 1 string, this hole is larger, significantly larger. So now getting the string through this finger is a whole lot easier because this hole is a lot bigger, right? All of these holes are a lot bigger. So that was a definite improvement, a definite goal, is to make the stringing itself a lot easier. And I think that's achieved. And it's thickening up. There's other parts that thickened up as well. The one he's talking about is that. The other side on the main finger had similar problems. There were some other parts that right now are escaping me where I, with the stomp on it test, had broken it and wanted to make it thicker.
Jack, I'm sorry to keep interrupting. There are a couple more questions in the chat. Do you want me to kind of feed those to you as they come up, or do you want to save them for the end?
Sure, we'll go ahead and do them as they come up. Why not?
Yeah. So there's
you're the only one who got to ask the other question, since we'll let other people.
Yeah, exactly. So there's the question about the TPU and whether you've tried using springs. Smart Hand, I believe that might be Ahmad, says that he tried the TPU 95 with the previous version, but after a while the hinges deform because of repeated tension from the user. He's just saying, if we think for a long time hand for users, he's wondering if you've explored springs or anything other than TPU.
So I have explored springs and other things, and I generally get away from them because, as I said last week, my main driver is something that can be made in a low-income country, right? My personal primary goal is a design that can be used anywhere in the world. Somebody in Africa, Nepal, right? Colombia, like the guys last week. Colombia's a little easier, but lots of places, they just don't have access to a hinge. I can't say, oh, get a, number 32, spring steel hinge, right? And use that. They can't order that from, McAster Car, right? If I could use stuff off of McAster Car, I would completely change my design. It would be totally different. There would be lots of differences if I knew, I could just say, oh, order here's a link on McAster Car, order that. Yeah. Springs fall in that category.
I remember you mentioned that last time, that your base assumption is that people have access to a 3D printer, and that's about it. Leather as well, because as you pointed out.
I figured they have a leather. That was sort of a decision made, and that they can get that they have a 3D printer and they can print, but they don't necessarily have access to McAster Car, which is, if I were going to use springs, I would be very specific, and I would just want to say, this is the link, go here, use that. And I would change the design significantly. I would also, as time goes on, I would like people to get better printers, right? Right now, as I said last week, I use a Creality S10, and that's sort of my baseline, right? It's like, hey, if I can print it on a Creality, okay. But if I knew I could get a much more accurate printer, a much more consistent printer, I would also change the design. I would have a lot more gears, and the fingers would all be much more mechanical, right? I would have less string and more mechanics,
Right.
if I knew I could get better printing, and better printing of better materials as well. Maybe get away from PETG and into some of the more industrial strength nylons, right? I would use gears in the fingers. That is the only way I have found where I can up that grip strength, right? I got to get away from the string all the way down the arm and all the way out to get a better grip strength. And again, that's sort of looking far forward, but it is a design decision. Sure, I could have made mechanical fingers that can grip, 60 pounds or something, but nobody else could make it.
There's a trade-off, yeah.
Yeah.
Alexander was asking about the OpenSCAD approach you're taking and whether you've run into any issues with non-uniform scaling. I pointed out that I'm kind of guessing you don't need to do any non-uniform scaling because this is for an arm, so you don't have to worry about fitting in a residual palm. Have you found any need to do any kind of non-uniform scaling?
Yeah, so that's a huge deal. And I would say it's all about fitting the residual arm, right?
Okay.
And so if you look at the OpenSCAD code, it is completely scaled non-uniformly, right?
Got it. Okay.
And to the degree that
so it's more scaling the arm components, you're not scaling the hand components so much.
Correct.
Yeah.
Correct.
Okay.
Yes, correct. So the problem just transfers to the arm.
Yeah.
And so yes, I just do uniform scaling on the hand, going back to the original.
And I think you said that last time that you're taking a measurement like every inch, right? Up the arm.
Right.
Okay.
Right. So for the socket version, it's taking a measurement every inch down the arm, the residual arm, and then I'm not scaling at all. It is completely lofting that shape around the arm.
Got it.
So that there's no scaling of the arm. It is sculpting the arm in code around that size, and that around the measurements you've given. And that's to get that socket better, because anybody who's dealt with, right, you can get bulbs in the arm, you can get all sorts of shapes depending on how the amputation was done, right? Whether it's a genetic thing or whether it's an amputation or whatever, the shape can be very different. So the answer is yes, very much so. And my solution to it is to not scale at all. It's to sculpt, it's to generate the shape in code. Yeah.
But Jack, I did hear you talking about the transition from Blender to Fusion and to OpenSCAD and some challenges that you hadn't addressed yet. So I do want to call your attention to the fact that Andrew and Alexander have developed a really interesting platform for customization and parameterization. It's a very interesting and potentially powerful platform, which they have got to the proof of concept stage for a design that Jeremy has been leading for, I'm forgetting for the Evo hand.
Right.
I mentioned it.
It's a whole workflow to enable this type of design where you want to build a fully parametric design. We're trying to create a standardized workflow for the design process, and then a web-based platform that's mobile friendly, that allows people to easily kind of capture measurements in the field and automatically sort of shoot that to the cloud, generate all the fully parametrically scaled STLs, zip them up and provide them to you. So we should compare notes at some point and see, because we're trying to build in a way where we can just plug in additional designs to the app by simply making sure they're hosted and shared in a certain way. And so there might be a lot of synergy in bringing your design into that.
Yeah.
Jack, I mentioned it in particular because both Andrew and Alexander are, seeking real jobs. And yet their technology is, I think, quite well done and sophisticated. And if it were a good match for you, you're the kind of coder and designer who might be able to adapt it to suit your purposes and help us keep alive a really promising but fairly technical project. So you should look at it. It's
Definitely.
Your priorities and the way you're going about this are great, but you should be aware that we might have a resource that you could make use of, and you might be a foster parent for something that we want to preserve.
Cool. No, I'm open to all that idea, right? Because I don't have a good solution for the e-NABLE community on that. So I'm open to what, right, other than what I've got here. And I would like to go further. As I said last time, right, the next step for me would probably involve some sort of scanning of the residual arm and going from there. But I would love to see, how you guys are working and see if I can work together with that. Right. Great. Definitely. I could jump to, I'll show you. Yeah. So anyway, so for scanning, I happen to be using Meshroom from Alice Vision, right? And for doing photogrammetry scanning, only because I don't want to reinvent scanning, and I'm not really. At some point, I thought, I have to get scanning to work, but Alice Vision is a really nice photogrammetry open source thing, and had pretty good luck with it. So I'll probably move in that direction, specifically for work I'm doing with Jeff Aaronstone, and I'll go ahead. Let me show you guys see if I can open up that real quick. Yeah. I have to stop share and then screen share. There we go. So this is a tool that I have been building with Jeff, and here you import the scan, right, into a 3D modeling tool, and then when you get the scan of the residual, this happens to be a leg, right? This is an above knee amputation. And then the prosthetist gets online and does their magic, which generally involves, them doing some carving or build up, right? So they might carve here, they might build up over here, right? And by them carving and building on the scan, they're defining what the shape of the socket would look like, right? And so then they build on stuff, and they have all these different measurements they want to do. So these are 1 inch circumferential measurements that that they want to look at and see sort of what they came from, what they've changed to, yada yada yada. And there's a whole bunch of tools here that prosthetist likes to use. And then once they've done their thing, I can run a tool that will generate a socket from that, right? And output that socket, and then they can take that socket and either send it to a manufacturer like Oster or somebody like that, or and there's various ways they can manufacture the socket from there. So we're working specifically on legs, but I want to make the same idea work for arms and other designs as well, right? So I don't know, this tool is very much goal aimed towards prosthetists and sort of their way of doing things. But I think there's a marriage here of, as long as they do this part, right, they're not as worried about somebody else sort of making the rest of it. Right.
And what is this tool?
This is an online collaborative tool by Operation Namaste that that I wrote with Jeff.
You guys developed this?
Yeah.
That's amazing. I mean, this is stuff we've been talking about for years, but it looks like you've gone farther with it than anyone else I've seen.
Yeah, this is a completely developed tool. I love this erase tool.
Yeah.
And this is a completely ground up developed code base for this tool, and it'll generate sockets from this tool. Again, mostly it's a workflow of take a scan, bring it in, let the prosthetists work on it. This is completely online and completely collaborative. So I could open a second window in Nepal and look at the same thing and carve on it, and all the changes I'm making here would show up on both screens. Right? It's like Google Docs for sculpting.
Really powerful.
Right.
Really powerful.
So it'll go back and forth. All the edits. All the edits are dynamically shared.
Alexander is asking. Oh no, this is from the guys in France are asking what's the public URL. They want to check it out.
Yeah. You can see it says localhost. That's because it's Operation Namaste, right? You can go there.
And that's Alexander is asking a similar question. He's saying, is this open source, or is there some intellectual property around
No, right now, we probably will make it open source one day, but right now we're keeping it to clinicians. You basically have to be a clinician.
Got it.
Of some sort, right? What that means, we still don't know, but you have to be a clinician. And so how we'll go, and Jeff is very open to the idea of reaching outside clinicians, but there'll be a line. There'll be, if you're a clinician, this is your world, this is what you're allowed to do. If you're not a clinician, this is your world, this is what you're allowed to do. And so there will be a line between medical professionals and non-medical professionals. I don't know exactly what it looks like yet, but we'll have both.
our friends here from France are saying they're doing that same job manually. I don't know if there's some opportunity for them to connect with you. I know that a lot of their cases, they do include medical professionals. Maybe there's a way to extend that.
Yeah. If you're working with a clinician, particularly somebody who's got any ISPO rating at all, right?
Excellent.
Email me and we'll figure it out. Right now, it's almost too much work, but we're at the phase where we're looking for more and more people. So, because I'm working with Jeff, and I know right now he only wants to work with clinicians. If you've got somebody who's got an ISPO rating of any sort, contact me. We'll let you in.
I like that approach. And Eric is saying the same thing. That makes sense. He says this precision socket work really should be medical.
Yeah. Particularly for legs, right?
Yeah.
Right now, I don't know how we'll get for legs outside of professionals, right? It's just the likelihood of falling over and really hurting yourself. Even if you don't fall over, just, now that I've been working with these guys, see a badly made leg in Nepal, and what it can do to somebody is pretty bad. And so you want to, and that's kind of what we're trying to solve is, oh my God, that's terrible. Let's make that better. But
and Jack, I'm sorry. Have you made the trip to Nepal yourself at this point?
I have not. I haven't got the family go ahead. And then we did a couple trips during COVID, but I didn't. I couldn't. Jeff could get shots really early, and because he could get it as a medical person, and I couldn't really get them, so it didn't work out. But yeah, soon. It looks like we might do something in Ukraine. I don't know. We'll see. Right? We keep ending up in that. Are we ready for prime time? Right now. It's used at several of the universities to teach up and coming prosthetists because when they went on COVID lockdown, they're used to coming into their lab and sculpting plaster. That's how this was all done in plaster for years, right? You would make a plaster mold of the recipient, and then you'd carve up the plaster, and then you'd wrap plastic around that plaster and make a mold of after the carving. And that's what they've been teaching for years. And so getting the school to make the jump from plaster to this has something we've done during COVID because we could. It's something we could do. And so we've been able to get into several of the universities and get them to sort of teach this tool as a way of making prosthetic sockets.
I'm just curious, Jack, do you have a name for the tool? Do you call it something?
Yeah, it's by Operation Namaste. And even though I made it, what do we call it? Collaborative CAD.
Okay. All right.
Right. There you go. So I forgot what we called it.
Yeah.
That's
brilliant work.
It's called Collaborative CAD. collaborative care network. Again, we're definitely in the beta test phase with that. So if you have somebody who's an ISPO rated person.
Well, I mean, it just strikes me that, I don't want to take us off topic here, but, for a long time, we've wanted to figure out how do we encourage more of our volunteers to make sure that they're working with medical professionals, especially here in the States, where I don't think it happens as much as it does in other regions where they're very good about it. And, I know some prosthetists have been a little bit, hesitant just because they, of the perception of e-NABLE and kind of what we're doing and how we do it. But finding a way of making them aware of this tool, I would think would make it much more likely for some of them to feel comfortable kind of collaborating with us because of the level that it allows them to kind of, work at. So this seems like it could be a good tool to somehow kind of work to leverage getting more of those relationships with the medical professionals in our region. Just a thought. It looks like it really could help to draw more of them in.
Yeah. I mean, I get it. In the States and in Europe, it's tough to work with a prosthetist, right? I mean, I work with Jeff and several other prosthetists mostly because they want me to make this software. And so they're like willing to sort of work with me only because they're like, well, I'll do this. I'll do some arms with you if you make this software for us. It's a good trade, right? But I get it, right? Having sort of worked with a bunch of them now, and they're trying to get paid. The sort of, and without getting too far into it, right? They get a fixed fee, generally 20, 30K range to make a prosthetic, and they've got to support it for 5 to 10 years. And I think we have a perfectly good thing. Like if we're making an arm, we can go, look, I'll work with you to make the arm. And they want to make the socket. They want to make the socket fit nicely and not rub and bend. All great, right? Say, yes, you work on the socket. You make it fit. I'll make the hand and the rest of the arm. And guess what? They get this plastic arm that is a lot lighter, quite frankly, a lot easier to use than what you're going to sell them from Oster. And it'll break in a year, maybe 2. And they're like, oh, I can't handle that because now what do I do? I go, you're gonna have to give them another one. It's gonna break in a year or 2. And so there's this problem because the insurance industry is built that somebody gets one every 5 years. We're gonna give them a plastic thing that's gonna break every year or maybe 2. They don't know how to deal with that. They're like, well, how do I sell that? Because insurance is only gonna pay me once. And so you have to sort of work with them and go, look, I will make you 3. Right, for free. Right?
Then they're relying on a volunteer. Well, is this guy still going to be around?
And then they're like relying on this volunteer to go, is this guy going to be there in the year when it breaks? And I'm on the hook from the insurance company and my recipient to have another one in a year when it breaks.
Yeah.
Are you going to be there in a year or 2 when this thing breaks and make me the second and third? So you have to convince them that, yes, I will be here for the next 5 years and make you a new one when this one breaks in a year or 2 because it's only plastic. And it's going to break, and that's fine. I'll make you another one. You have to convince them of that. Not an easy sell, right? When they already have this thing where they can buy one from a reputable manufacturer that is heavy as all get out because it's built like a tank because it's got to last 5 years.
Right.
And so I get it. It's not easy, right? And there are lots of roadblocks that are in the way, and they often come back to health insurance.
Right. It's not easy and it's understandable, but the result is that there is a whole class of potential user who falls through the cracks.
Yeah.
It's interesting to sort of hear that you're now, apparently after all these years, you seem to still have 1 foot squarely planted in each camp. You're working with the prosthetists. This is clearly open source and designed for non-prosthetists.
Yeah.
If you've gotten some new insights into how to bridge that gap, Jeremy described, that the restrictions on this very useful software might be one such tool, but if you have other insights, it's a good time to review them.
Yeah, I'm open to talking with you guys more about what you've done. My current plan is to go down this path that I am with Jeff, and take what we've done for legs and just do it for arms and say, look, here is a community that you work in this tool and here's when you've crossed the line to a hobbyist, and here's where they're allowed to contribute. And that might be in the manufacturing of the hand, right? And we would sort of vet certain groups, right? And go through e-NABLE and say, somebody like Eric Brubar, right? We would all know, go, yeah, he's going to do this. I trust him. You know, somehow say, yeah, he's going to make another one. He'll still be there in 3 years, right?
You know,
just to get the prosthetists going.
Just a thought here, because I really like your approach, Jack. It's really heading in the direction we want to go of getting more of the involvement in the medical professionals. And it strikes me that the main challenge is what you're saying, the assuring them that you will be here as a volunteer X years from now, which is hard for them to have confidence in. I wonder if it's worth thinking about leveraging our community such that, you know, if the device that we issue them is designed and it's scaled to fit them and all that, what if, you know, as soon as you make one for them, for a patient, and it's done a certain way, we could potentially put a call out to the community to say, hey, somebody else want to make one of these same devices at this same size and produce 2 or 3 more at the exact same size right up front and just give it to the prosthetist so they already have them ahead of time. Is that, would that be a possible approach, or does...
well, I think it would be more generic than that. I think what we need to get to is a point where we can convince the prosthetist that the community will be there in 2 years, that whoever made this thing now, right, may not be there, but there will be somebody of equal caliber there because there's this large community and this that the community will vet that person, and the community will say, you know, whether it's through badges or things like that, that the community could go, yeah, I'll have another highly skilled person 2 years, because the upsell is not only that, is that you can get them one every 2 years. They might want to make adjustments, right? Arms change, things change, people get fatter, people get skinnier. And so they like the idea of getting a brand new design every 2 years, right? That would be a benefit to them, right? If we built it again, anew every 2 years, they would see that as a massive improvement, right? And then the fact that we would get them 2 or 3 at the same time might be 2 or 3 different types would be another benefit that we can provide them, right? They generally provide one arm, right? And maybe it's myoelectric, you know, and whatever, and it's really nice, but it's one, right? And it's heavy. Another benefit we could say is, look, I'll give you 4. I'll give you a 2-tree, I'll give you a Kwawu, I'll give you a, you know, I'll give you a thing that's just flat for doing push-ups. I don't know. You know what I mean? And we're going to give you 3 or 4 of them. And there will be this community that we guarantee the community will be here. If the person who made that isn't here, somebody else will be here 2 years from now when you come back and say, hey, this one broke, I want another one. It's the community that's gotta provide that reliability.
And maybe, you know, maybe we can leverage our badging system. You know, if we have a certain number of people that have been certified for that design, you could tell the prosthetist, we have X number of people that have been approved for making this kind of device. To give them a little bit more confidence.
I think it's sort of what you're selling them is the stability of the community, right? That e-NABLE,
you have a pool of resources.
is stable, right? Any one maker might not be, but the pool is stable, the community is stable. That's how I would sell it, right?
So we are coming into our final 5 minutes here. I think we've covered pretty much everything that came in through the chat. So I hope I didn't interrupt too much there, Jack, and interfere with your presentation. But is there anything else that you'd like to go over, or does anyone else have questions?
I'm looking down because I'm looking at your list to see if there's anything else that you guys had asked. While I'm reading this, I would just say, hey, I'm always open to new ideas. Email me direct or put it on the e-NABLE Hub. I don't get on e-NABLE Hub a ton, but I get on often enough. I'll get to it within a day or two. And if I don't if you don't see me respond within a day or two, email me or hit me up some other way, because maybe I'm in Nepal. I don't know.
That's a good way. I like that approach, because you said this earlier. If you post questions or comments in the hub, that way other people can see them from them too. So try that.
Yeah, but sometimes you have a really specific thing and you just don't want to make it public for whatever reason. That's fine too.
If you don't mind, do you want to just throw your email address in the chat for us, for anyone that doesn't have that?
So if that's not there already.
And when we share this recording, we'll make sure to share these links and other information that came up in the chat along the way.
So, I mean, in the last minutes, I would just follow up on something that John brought up last week is, hey, you know, what do I think e-NABLE can be doing and stuff like that. And this is a personal feedback, and I'm, you know, don't take it personal, and don't be, and you know, it's just my own personal view, right? Is that what e-NABLE does really well is bring awareness to limb differences, right? That should be as big of a mission statement as making them, right? And that and whether it's, you know, the kid who goes in with the Iron Man thing and waves it around, or whether it's going to a maker fair and having a whole bunch of e-NABLE devices on a table and people picking them up, just brings, and, you know, and maybe doing the try, you know, they've got the thing like one of Eric Bubar's sort of, like I was showing with the box and block where they can try one out. Maybe it's a school. I see it awful lot in e-NABLE where some school says, we're going to make 100 hands and we're going to give them to e-NABLE. Between me and you and the people on this call, you've probably given a hand to everybody in the US who needs one, right? Yet I still think there's huge value in having that classroom make a bunch of hands. And that value is limb difference awareness, right? That value is getting a bunch of people to go, you know what? Hey, this is a thing. There are people with different limb differences. And even if it's limb difference or body type difference, it just, that awareness, I think, should be a major part of e-NABLE's mission statement. And don't shy away from it. You know, it's okay to say, hey, you're doing this festival and you're gonna have a lot of hands. You're not making one for anybody.
Mm-hmm.
If you're doing a classroom and you're going to make a bunch of hands, do it so that you're raising awareness of limb differences, not because you have to make a hand for some kid.
Jack, could you just say out loud why raising awareness of limb difference is a good thing?
I don't know, I thought that was obvious. But yeah, I mean, I guess just the social stigmatization, I mean, in the US, you know, the few kids that I've actually met and made hands for, you know, they really suffer with different body type differences. And I don't think that's different than somebody who's overweight or any other body type difference, right? But it's probably a little worse and a little bit different. And so the more you can just make it seem fun and oh, not a big deal. If somebody has made a hand in middle school and they never saw anybody with a limb difference, but they made these, you know, e-NABLE hands and they did this whole project. And then in college, they see somebody with, you know, limb difference, they're going to be just much more easygoing about it. It's going to be much more, but hey, we made hands. Isn't that cool? Hey, you know, and
Sure.
That's going to be huge. And the severe difference, of course, in Haiti or Africa, a lot of places, if you have a limb difference, you're not allowed on the bus, right? You're not allowed in the store. They're just like, no, you're not allowed. No, you can't get on the bus. You've got a missing hand, right? And so for me, you know, just having a natural looking hand is a big deal because it allows somebody to get on the bus. It doesn't have to function at all.
Yep.
It just allows them to get on the bus and not get ostracized in a very severe way.
Good answer. I'm glad I asked.
Indeed. And I just want to thank you so much. We're going to have to wrap up here. I need to get into another meeting. Jack, this has been a really phenomenal presentation. And as I said before, your work is just amazing. I really appreciate everything you're doing, as I'm sure everyone else here does. So thank you so much for doing this today.
Thank you. It was loads of fun.
There are always opportunities to address other questions or observations. That's what the hub's for. So please, anyone watching this video, you know, post comments on the post, ask questions, tag Jack in the hub there, and keep the discussion going. All right. Thank you so much, everyone, for joining.
Thanks, everybody.
Bye-bye.
Thank you.